Okay? Once again, I'm starting a little late in the recording, but when you get an equation, you are going to get an interval that tells you where on the curve I am looking for my answer, because you know sinusoidal functions go on forever. Let's do one as an example. First, we're going to simplify. The question says, if 2 sine x plus a 1 is equal to a 0, what value of x makes this true? Sound familiar? We're going to push as much, it's going to do basic algebra, we're going to push as much of these, I guess, variables, or sorry, all these factors, all these numbers, all these terms, to the other side to make life easy for us. Okay? So I'm going to get sine x to equal negative 1 over 2. Okay. So where do we go from here? Some of you might just jump to the graph and be like, okay, where does sine x equal to a negative half, right? And maybe you can figure it out from there what your final answer is. Some of you might decide to use cast rule because sine x being a negative value means we are going to be in quadrant 3 or 4. Okay, so I'll just write, using cast rule, x is in quadrant 3 or 4. Okay? So I'm not actually going to do even quadrant 3 or 4. I'm going to go straight into figuring out what the related angle might be. So if in quadrant 1, right, sine of x would have been positive 1 over 2. Right? If it was in quadrant 1, because it would be positive. That means my x would have been pi over 6. Okay, so this is going to be my acute related angle in quadrant 1. What would the angle be for quadrant 3? What would the angle be for quadrant 4? And there's your answer. So let's do this. For 0 to 2 pi, so in other words, a regular circle, quadrant 3 would be, in quadrant 3, my overall angle would be, why is this here? There it is. Quadrant 3, so, there. So at what angle does sine x equal a negative 1 over 2? Well, it'll be 7 pi over 6. What about quadrant 4? What would my formula become? 2 pi minus. Yeah. So I'm just using cast rule here. There. So now I have 2 answers. Well, and does that make sense on this graph? It does. If this is negative 1, that's negative half, and I should have 2 answers. I'm not done. Why? Just for the sake of argument, just for the sake of having an example, I also made the interval cover 180 degrees or negative pi, so to the left side. So let us cover another interval for negative pi to 0. If it's in quadrant 3, Oof. Think about it. We're now going in the negative direction. This is going to break some people's heads a little bit. If I want to calculate a triangle in quadrant 3, I'm doing this. That might confuse you. Maybe I shouldn't write it this way. Let me think about this a little bit. Yep. I'm going to do the same picture, but let me try to explain it a little differently. Dang it. Okay. So for quadrant 3, again, you know that the triangle I am dealing with is that. But I'm not rotating in the positive direction. I'm rotating here. How do I communicate this angle when you know that the acute related is going to be pi over 6? Let's first figure out what this angle is. A full 180 degrees, a full half, I guess half of a circle will be negative pi. And how much is this? Russell? Yeah, it will be negative pi, which is all the way to the x-axis here, and then I'm moving back. Seriously, how else? So I'm sure there are other ways you can communicate how to like this angle. How can we communicate that in a simple manner using our related acute angle? Well, before, if you remember, in quadrant 3, we said, hey, this is the same as a full 180 degrees plus a little extra. When we go the other way, you can say it's a full 180 degrees minus that little bit to describe the angle we've traveled. So for quadrant 3, the angle would be negative pi plus pi over 6. And somehow, in that short period of time, I misplaced my green pen, which comes out better. Anyways, and so the angle would be negative, 5 pi over 6. In the same way, if it's in quadrant 4, this is the triangle I'm dealing with here. How do I describe this angle rotating in the negative direction? The angle in the negative direction is the same as negative pi over 6. The reason we have to go through this, again, I'm going to go back to my little drawing of the sine curve. It makes sense for us to have 4 different answers for this one equation, because if I'm looking for the y value of negative 1 over 2, I have 4 different locations where that dotted line intersects. So a lot of little details you have to keep in mind as you work through these equations. I'm going to stop us right there. It's just one example, something for you to see, even if you don't quite understand it. Tomorrow when you come in with a cooler head and a fresher mind, know that we're going to be exploring the Cartesian coordinate in a variety of different ways, different directions, to get the answer that we want. Okay? That's it. Yes?
Isn't it negative here? The negative 11 over 6?
The 11, this part?
Yeah. Shouldn't it be negative?
No. Positive
no,
2
not
pi.
this one. But the negative.
This one?
Yeah.
It is negative. Negative pi over
I
6.
just copied it down.
Oh. So I don't. It is a lot. Again, I will try the second example tomorrow, starting with a visual so that you know what the answer should be. And then we will work it out algebraically so you can do this without just a sketch. Okay, and you can actually get exact values for it. All right? You can put your stuff away, cool your heads, get ready for lunch, do what you need to. I will dismiss you when the bell... Pardon? I don't want to go any further than this. I did one example because I wanted you to know what we're going to do tomorrow so you have an idea of what's to come and it's not just completely new.
Sorry, I'm leaving at 10 tomorrow.
I will record. Well, I will have to because there's some people who's going to be missing. Yes?
What time is lunch?
In 10 minutes.
I did not know that.
Alright, this will go up too in case you wanted to take a look at it.